So now we are going to have a presentation by CIE, by Christophe Courtoy and Vincent Pilon. So Christophe, you're already sharing the screen, so I will leave the ball to you.
Thank you, and thank you so much for the invitation. Very pleased to present this half an hour little brief over training. So how can we rethink the training ecosystems for Rotorcraft? So I'll quickly introduce myself. Christophe Courtoy, I'm a product manager. I'm in the defense group, but I've been like 15 years in the civil division as well. So really working around innovative solutions that we can pull. So we're remote here from Canada, and there'll be Vincent will be joining me a bit later. He's going to do the second half of the brief. So again, thank you very much for this opportunity. So if we go into quickly, just a quick overview of the presentation. So we're really, CIE is really a high-tech company, really having 3 different segments of operations. So civil aviation, military and defense, and the healthcare industry. So our mission really is to be at the frontier of digital immersion world for a safer place. And our vision is really to be the partner of choice with digital immersive solutions, really around safety, efficiency, and readiness. So a very similar mandate as what the ESI is striving for. You can see here on the chart that we have a very large footprint, I would say. All around the world, we're now 11,000 employees. We have a lot of different acquisitions, 35 countries. And what's important to the takeaway of that slide is that because we have 3 sectors, we have a large footprint and many R&D activities around the world is really helping us innovate a lot of ideas and really the culture of ideas and innovation in the company. So I think that is great. And something interesting is that there's about the same number of instructors than engineers. So it's a very nice mix. So we have training centers and also operating live flight training. So really innovation, cross-feed one sector to another. So that is something great around CIE. So the idea today is really to talk around training, right? Training innovations. So it's always what are we trying to solve as in terms of a problem, right? So and training innovation is not just technology. Training innovation is also how do we change the way we deliver training? How do we challenge the status quo? So training innovation is around people, right? It's around instructor, pilots, and also the people running these training centers. So it means what? It means how can we optimize the instructor workflow in the training delivery? It means as well, how do we adapt to a new generation of students, new training methodologies, and cost is always a matter, right? That's key into being. We need to be trained efficiently so that there's more access to training for all types of different pilots and platforms, aircraft types. So really about making that continuous improvement loop to be safer, faster, and better. That's always what we strive. So here, what we're going to do is talk around that. So we're going to talk. So it's going to talk beyond technology, some lessons learned that we have, and we're going to first start talk around some of the really deep transformation happening in the US with the US Air Force. So, oops, sorry. Okay, so the US Air Force, like about 2 years back, they really had to reimagine the way they wanted to deliver learning to their airmen. The traditional training was really broken, and it was not meeting the needs. So it was taking too long. They were really severely lacking pilots and instructor as well, because instructors are pilots, and they had a lot of workload, these instructors, and the training was really serialized. So it was really the same construct over the last 6 decades, that there was not really any transformation happening. So what they did is really launch an innovation challenge. And that's really what became the Pilot Training Next initiative. So really they were forced to innovate and rethink training. So this 2 years experiment really as a skunk work, it was really just think differently, right? So then they what they did is they inserted new type of training medium, right? So you can see on the screen there are some they were inserting some training device. You can see it was all CUTS hardware. It was on a plywood chair. They really went into pull a lot of involvement from industry, a lot of academia, government, industry, and really some CUTS building blocks. So that's how they can actually approach how can they change the way they were running training. It was essentially a Microsoft Flight Simulator, if you say, running a T6 model. And then they started to build and bolt on some elements to that, like a virtual coach. So automated assessment and a virtual coach giving like live feedback and progressive, right? As you were training, you would improve and change the cue to be more tailored based on your profile. So that experiment was really getting pilots straight from this immersive training device, going straight into the aircraft. There was no traditional flight training device and everything. And the mantra of the team was really, if you didn't break it, it means you didn't go far enough. So it was really pushing the boundaries, really to be disruptive. That was the main intent. Then what happened a bit after is that all of the great lessons learned from that made a transformation from pilot training next to pilot training transformation. So in the US, it's what's getting called UPT 2.5. So it is really the going from the prototyping phase with pilot training next into an enterprise deployment of that new training construct. So the main pivot there is really going from a student-centric approach, really with some individualized learning path. So the training device, as you could see from the first to the second image, it was really like drastically improved. So they upscaled the system, going from USB controls to force feedback controls, but they kind of still remaining with some generic throttles. They still had a mouse on the side. They had no really cockpit interactivity in VR. So that's the current system that's getting deployed in UPT 2.5. So part of that program, CIE has a place. So we're kind of building the learning management system. So everything that's happening in this training program is always backed up and it's already associated with some training events, some lessons into a learning management system. So everything is tracked. We have some pilot performance tracking with XAPI. So we run the learning management system. We track all the different competencies of the different students, and we manage the overall training process with the US Air Force behind that. So what is the transformation there? So going from UPT 2.0 to 2.5, as you can see on the chart here, it was really, they reduced the number of flight hours by about 40 hours. They reduced the simulator hours now by 10 hours. But in compensation, they added 126 hours on these ITDs. An ITD is really the acronym for Immersive Training Device. These are the VR trainers you could see on the screen. So all in all, I mean, it's still like 90 hours additional of instruction. So they had more instruction. They reduced the more heavy, the more costly live flights and simulation hours. So adding about 90 hours of instruction, but still running into a shorter program. So that's really promising. So the metrics at the end of that is that some assessment from instructors which are outside of the program really didn't see any shortfalls into the new pilot getting through that program. So that transformation is really significant, and it's not just the US Air Force looking at that. So most countries are really following that very closely and see what can they adopt from this transformation. So, oops, sorry. Okay, so in parallel to that, CIE have developed we develop our own training solution that we call the CIE Tracks Academy. So TRACS is really the acronym for Training Acceleration. So this really goes into the same principle at Pilot Training Transformation. I would say that, I mean, we of course have our own choice, so we've made that a little bit different. So I think our immersive training device are a bit more higher end, so we have more we really inherit all of the simulation not from the game industry like Prepper 3D, but really migrating the same level of fidelity that we have on our advanced flight training device. We use the same software technology there and migrate that into this VR platform. So Tracks Academy really is a complete data-driven ecosystem, right? So it goes with academics and some hands-on lesson, and the same principle as what we're deploying with the US Air Force. All of that is again backed with the learning management system. So the training continuum really is really based upon some advanced instructional design methodology, right? So we define some competency hierarchy, learning objective, lesson flow, all the different prerequisites to make not a single path learning system, but really to be more dynamic, really adapted to the need, including some AI and machine learning building blocks for some adaptive learning modules. So the three phases you're going to see here really is learn, practice, perform. So this is really how we kind of well, it is more like a tagline than really a waterfall process, learn, practice, perform, but it's really looking into how we transform the training delivery around these three phases of the training, right? So in the learn, we introduce some VR courseware, so and as well as really mobile ready type of lessons. So we can really train anywhere. We have some tracking on the progress of the computer-based training, and then rich courseware with like, and the courseware in VR means what? Means all this spatial awareness, and also it can be interactive with some controllers and some end tracking. So really make that a lot more engaging courseware than classical slides. In the practice, same principle as PTT, we also insert new type of training media, ITDs. So what's happening with these ITDs as well is that they have some embedded self-paced lesson, right? So again, there's a virtual coach giving you advice into how to better perform, track your progress, provide some automated debrief and grading. So that self-paced is not saying that there is no instructor in the loop. It's just we change the ratio of number of instructor per student ratio. We change that, so we can monitor multiple students at the same time from the instructor perspective, and all of that is backed up with data, with some analytics. So they're really supported. So that's how we can reduce their workload, but still be able to have more throughput of students. The headset again is a very high acuity VR headset. We have force feedback controls, cockpit interactions. And then the last piece is really the perform. This is where you know, we use the existing known type of FTDs, where we bolt on some telemetries so that we can do some acquisition of data, do some analysis, performance metrics. So these training devices are the one that we currently know. It's just that we augment that with some data acquisition. So that system is getting introduced on the Beechcraft T6 and Grob 120 TP curriculum. I mean, there's a lot more on the slide, but for a matter of time, I just put here the QR code. So if you just scan that with your cell phone, you'll be able to be directed straight into a video that's posted on YouTube. So you have the full 4-minute brief out there that's going to help you learn more if you're interested. So going into the next slide here. So as we said, well, what does it mean being learner-centric, right? I mean, typically whenever the tutoring delivery is really focused into a single path, really teacher-centered, we have like predefined content, we have a flow, all of that is acknowledged, approved. So it is really a single path learning. So, but how do we transform that? You know, the U.S. Air Force Major General Wills leading this transformation in the U.S. is really pushing forward that it's really the instructor that needs to adapt to the student, right? So that's how you get the best outcomes. So it means what? It means that we need to build tools to support instructors into doing this pivot, right? And how can we gain efficiency and effectiveness in training programs? So we need to build tools, but tools around the web, right? So the first thing is we need to understand pilot profile. So I mean, here I'm not going to go into the exhaustive list of all these building blocks, right? But clearly you can see that the trainings to be adapted based on the flight career of the pilot. There's some biometry play, and that, I mean, are we pushing too far? Can we see the cognitive workload of a student? What's this? Is the learning performance? Is flying performance with all the different aptitude the student have? So by doing all that, capturing really the pilot profile, we really have like a 360 view of the learner. And from that we can really enhance the development. So it means what? I mean, some of the it means that on the program with some metadata tagging into the lessons, the learning objectives, as we said, and some AI and machine learning play, we can start really to think about getting some personalized learning, training recommendation, adaptive training, and we can even at some point have some indicators into what should be the career path of an individual, and that maybe is more in a play into the defense side, because they're streaming to are they going to be transport, fast jet, or helicopter pilot, but that still applies as well into I'm sure into the civil space. We can see as well that I mean, advanced air mobility, there's going to be just really a transformation into the mobility that's coming in the future, right? So a lot of new pilots will need to emerge. They will come from a lot of different backgrounds with different skills, and even eVTOL as an example, flying will be a different skills than a standard rotorcraft, right? So these platform will be more autonomous, a lot more advanced. So we really need to shift into how do we get the right training for the right person. So that really all goes down into the root of understanding the pilots and what are the gaps to fill. So going to the next one here. So as you saw, I mean, I'm a product manager in the defense group, right? So this defense sector is really leading the transformation. You can see all these green suits here. But I mean, it's more than that. We saw the first FSTD that got certified. I think it's a great technology that VRM has put together for that, Robinson. But in the defense, I mean, the technology is there, right? It's proven, it's really adopted. So we have a play with US Air Force. We've deployed numbers of different training devices. Some were pure virtual, some were mixed reality. You can see on top right. So we have like physical buttons with some tracking cameras, be able to track fingers and operate. And in that case, it was really into a mobile footprint. So a lot of different projects that we've delivered, supported by products, obviously, and something that we're going to announce, and I'm inviting all of you guys, if you have a chance to come to Orlando a few weeks from now for the ITSEC 2021. We're going to launch the Track Academy Crew. So basically, it's really extending the applicability of what we did for fixed wing tandem trainers into helicopter and crew training, right? So in there, what we're going to do really is how can we teach how to hover. Hover is in principle easy, but it's very hard to accomplish. So we're going to build some interactive courseware on the chair you can see on right. So we're gonna like virtually teach people how to hover with some pre-recorded interactive live instructor demonstration. Well, the playback on these chair. Then we're going to do as well a virtual coach into hovering. So And that virtual coach can be alone, or it can also be a real instructor that's being linked. So we can see two chairs. There can be an instructor on the seat with the students, and then we can couple these two chairs flying together. So sometimes learning how to fly is gentle movements on the stick, and I mean, there's how you learn that. You learn a lot with muscle memory, right? So, and how actually you need to handle the controls. And also other different techniques, backdrop techniques, etc. Right. So we're going to build all that into our courseware with the virtual coach as well. And then what we're going to do as well is really performing a mission as a crew. So we're going to have a pilot, a co-pilot. They're going to see each other as an avatar linking the chair. So that's kind of something that we're going to unveil in 2 weeks from now at ITSEC. So you guys are really welcome to come and see the different progress we make in that sphere. Which I think is quite relevant to the Rotorcraft that we're talking now. So, I mean, I spoke a lot around all the different change that are happening, revolution in the defense industry. But I mean, really, all these innovation are really agnostic of the sector, right? So most of these things can be applied to the civil space. Indeed, what's happening is that the defense sector is much less regulated. So they have more rooms to actually go outside of the boundaries, but there's still a lot of lessons learned that we can take of that and actually change that, right? So how can we change a training paradigm into the way we conduct the training delivery, the different training medias alongside with it? So really, I think innovations are really agnostic from the sector. So I think now we spoke around training innovation. Now we're going to talk a little bit around training device, because this transformation was a perfect storm, right? Is how can you adapt new training methodology, but at the same time there's new type of training media that goes along with it. So that's where that's what we're going to talk next. So basically, right? What is a training device? I mean, if it's an XR, so just for some of the people on the line, XR is extended reality. It is really the umbrella that covers virtual reality, augmented reality, and mixed reality. So, I mean, all these things cross-feed one another, obviously. So these new type of innovation are really a good lead-in into getting new products out there, right? So I mean, if we change the visualization, it just unlocks a lot of different things, right? So on a new simulator that's based on XR technology, we don't need to transform everything, right? It's really transforming the visualization of the headset. So by doing that, no need of a dome, big projectors, big screens. What happens is that we can shrink the footprint of the system. So shrinking the footprint of the system means new ways of queuing and new ergonomics of the structure, etc. So, and in the same vein, we also see these new eVTOL getting smaller footprint aircraft, very small aircraft, lightweight. So these two things together are really make room to actually create new type of training device. And as well, these type of small device, I mean, we need to have really cost-effective training solution for these small rotorcraft, right? Because, I mean, we cannot have very expensive equipment for very low-cost system. So the ratio needs to make sense. So we need to rethink a little bit the different product to meet the expected demand and really to be cost-effective. So really what's happening is that we can really broaden the reach of simulation because of this smaller footprint and more cost-effective training solution. But what's important is that it should not do that by reducing the level of fidelity of simulation. So it's not because it's a new type of visualization that it needs to be a lower fidelity simulation, right? So typically we tend to see, well, it's VR, it's game, it's low cost. Well, I guess cost goes a bit sometimes with the fidelity. So we should not compromise fidelity, really, if we want to leverage this type of device into improving the safety record. So most of the building blocks you see on screen, I mean, they're not different. It's just as I said, these new type of XR technologies are really the enabler to move forward. So the next one here, a quick overview on technology, right? So everybody knows what's the VR reality, virtual reality, right? It's you have your helmet on, you're just into a different world. You don't see anything, right? It's really you're fully enclosed, so you have no interface with anything else, right? So that's the pure virtual reality. So you can still interact with some objects, but you'll not see your hands, you'll not see anything, right? So there just need to be a fully tracked system if they need to interface with some hardwares. The other two are really mixed reality, where there are some physical elements. So the first one on the left, see-through mixed reality. Well, what is that, right? So you can think around what is a HUD on an aircraft, right? It's really an optical combiner, except that it's not just layout symbology, it's the full screen, the full rendering, right? So you can see an image taken with cameras from within a see-through mixed reality headset. It's really impressive. So anything is real. The only thing is, whenever you go see through the window, there is a mask, and we just render the screen, right? So and we render on the screen what should be out of the window. And the other one is really seeing the world on screen through cameras. So that is the camera-based mixed reality. So they all have their plus and minus. And in the end, what's important to realize is that we need to find the right training device for the right training task, right? So we can do everything on this more high-end system, but what is the right training media for the task? And that's really key. So all of these, in fact, they have unlimited field of view because you have a full tracking. What is important is understand that there's an instant field of view. So that's what's really what you see at an instant. What's the field of view of the headset? So yeah, so some challenge around technologies that we're going to talk into the next slide. So no matter what type of training solution you have for your visualization, I mean, again, the simulation is really independent from the type of visualization. That's really key to keep in mind. So going into the next one is talking a little bit around challenges and choices, right? So these technologies are great, but they're not perfect. None are perfect, right? So the first top left pictures you're going to see, right? So what's happening here is that whenever you have your two eyes and see a real world, you have this focal distance, right? So your eyes are always adapting into where you're focusing. What's happening whenever you put the headset with a screen in front of you is really where, I mean, you have this vergence and accommodation that your eyes needs to change really the focal distance. So I mean, what does that mean? I'm not an expert into that, but what does that mean is that the feedback we got was the natural fit, the how much of the natural experience, how long can you train, get your the eyes trained, how long can you really get sitting on the device and train, is really a major factor. So this is where we saw that the optical see-through technology was much easier for an adoption perspective. Because it's basically a standard conventional FTD without any displays, but it's almost a wearable dome, if you can say. So resolution field of view, I mean, there is huge progress on technology now. Displays are much better. If you think about the resolution in arc minute, I mean, these type of headset can be very close to conventional displays. So it is great. As good as them almost. So and it's getting close to U-minor resolution. So some vendors claim U-minor resolution. It is true in some area. I mean, a bit misleading in others, right? So because basically, I mean, to actually get the full human eye resolution across the entire field of view is not there yet, right? So this is why, again, we do think that the optical see-through is really a nice solution because you don't need to actually go through pixels and limits of a screen to actually get the real feel, the real cockpit, right? And as well that the more you need to compute, the more computing heavy the system is. So that's a bit into, and again, there's always a factor of, do you want to have more lateral, more vertical field of view, etc. So another challenge is really hand tracking, latency, and even if you think about crew training, it's not just hand tracking, it's full body tracking, right? So there's always challenge with occlusion, so that's why we need to have a lot of cameras, small to actually track hands if we go with that type of technology. There's other tracking technology as well, but it's always a challenge into getting the right tracking and body tracking whenever we talk crew training. So some occlusion, and we always need to in a VR application always need to have a very tight alignment between the real and the virtual world. The physical play into these things. So again, when it's VR, it's not because it's VR that everything is virtual, including no buttons. So we can have some physical buttons in VR with the right tracking. So the physical element design really falls with the tracking. So we can have either virtual or physical switch. I mean, the physical switch are really key into getting that right muscle memory, and sometimes as well you do operate some levers without actually looking at them, right? So that's why if it's purely virtual, nothing physical in the cockpit, you can do a fair amount of training tasks, but not everything. So the more you bring physical elements, you augment the training capability of the system. So and again, the haptic feedback is key. We need to make sure that it's not intrusive. So big gloves and stuff is a bit cumbersome and not ideal. So yeah. So the last element really is the video chain, right? So this is the video chain I showed here as an example, is really showing what's the complexity of a camera based mixed reality, right? So it is really everything is always seen from a screen. I mean, there are cameras that are just capturing the outside world, and then we combine software-wise the synthetic DIG, so the synthetic rendering. We do some camera processing, video merging, masking stuff. So it's great, but comes with a lot of complexity as well, and not the natural feel, right? So, and again, the cameras are great, but cameras are never as good as your eyes. So I think what's important to understand as well is even whenever we have very high resolution display, cameras are never at par to actually properly feed this high resolution display. So the experience is never as great as what you can really see. So the next one is really now I'm going to hand over the mic to Vincent. So I kind of explain a bit the DNS Perspective product technology. So Vincent is going to talk a little bit more around the play and of all of this for the eVTOL and the advanced air mobility.
Thank you, Christophe, for this enlightening briefing, and thank you, Giuseppe, for inviting us to participate in this conference. So my name is Vincent Pilon. I'm product manager for the new markets in the CIE's civil division, and this includes the advanced air mobility markets. So as you have seen in the previous slides, there are interesting new technologies and innovations that are being deployed in the defense markets today. And these technologies can also find very useful applications in civil markets. So we feel that the XR technologies, and more specifically, as Christophe was saying, the optical see-through mixed reality technology is a natural fit for the advanced air mobility pilot training solution. So let me explain why we think that's the case. So first, there's the financial argument. The advanced air mobility market is going to operate under a different financial model if you compare it to the traditional aviation market. The overall operational costs will need to be lower, and this includes pilot and maintenance training. So the traditional high fidelity training solutions, what we refer to as the full flight simulator, does not align well with this financial model. So that's the first argument, financial. Then the second one is the training device requirements. So the advanced air mobility aircraft, the eVTOL aircraft, have the vertical takeoff and landing characteristics. And these bring additional training device requirements that are challenging to meet with the traditional full flight products. They're not impossible to meet, of course, but they will be costly and they will contribute to increase the financial challenge that I just mentioned in the first argument. The mixed reality visual solution does offer this infinite field of view solution that Christophe described, and a perfect 3D rendering with no parallax and no depth perception errors, and all of that at a lower cost. And the third argument is the scaled up demand and the global deployment plan. So the advanced air mobility market is expected to grow rapidly after the initial ramp up phase. So this growth will require to have multiple devices, multiple training devices deployed simultaneously in different parts of the world. And of course, the mixed reality simulators would be a lot easier to deploy at scale and at a lower cost. So these are the main arguments why we think that the optical see-through mixed reality will be a good fit for the advanced air mobility pilot training. But there's more than just the visual mixed reality hardware solution. There's also a need for advanced technologies in the image generation itself. And in this short video, you will see the advances in the next generation IG capability that we will be publicly announcing very shortly. So here you will notice the light reflection in the wing, under the wing, the engine cowl, and the windows. And as you see the aircraft flying over the scene, you notice the trees, buildings, and all of the 3D models that will also be critical for urban training. So this video was developed in the San Francisco Bay Area. So in this next clip, you see a good view of all of the 3D models. So all of these buildings were automatically generated in the visual database using AI engine and with a geotypical texture. So the representation is not an exact replica, but as I was saying, it was automatically generated, and the textures are representative of the areas of the San Francisco Bay Area. And here you see the advanced features of lighting at sundown, which is also characteristics that will be more important in the urban area training. And a few more notes here. So the visual is definitely an important technology that will need to be enhanced and brought to a higher fidelity level for advanced air mobility training in the urban environment. As mentioned, the database content is also a key element. The 3D models will need to be properly replicated in the environment. The geotypical 3D models, we believe, will be sufficient in most of the areas that will need to be simulated. But we do believe that geospecific insets within the geotypical representation will be required for the takeoff and landing areas. So the 3D content is one thing, but the city will need to be animated as well. So the moving models will also be critical to be properly represented with high fidelity. I'm referring to ground vehicles, aerial vehicles, but life forms as well. The crowd simulation, what we refer to as pattern of life, as you see here, this representation of Trafalgar Square in London is an example of the simulation fidelity that will be required so that life forms and crowds react in your simulation environment as unplanned events occur. If you need to perform an emergency landing in a park or in the middle of the street, for example. So this will also be part of the critical synthetic environment solution that will be required for the advanced air mobility pilot training. Another important point to mention here, which you see on the right side of the slide, is a wind simulation around structures. So as you land in the urban area and as you get below the building maximum heights, you will start to experiment with aerodynamic effects. So it would be very important to properly represent a realistic flying conditions that the advanced air mobility pilots will need to fly into. You will need to have proper wind simulation around 3D structures. So there are some techniques that exist today where high precision wind flow simulations can be generated using techniques known as computer fluid dynamics calculation methods. We think that these will be critical also for the advanced air mobility training. And just the last point about the ATC simulation, of course, will need to be also replicated in a way that's realistic and will provide realistic pilot workload experience. So the CIE Mixed Reality Simulator integrates all of the innovations and technologies that we described earlier in the presentations. The main components: a level D capable aircraft simulation, so the highest level of aircraft simulation solution, a physical cockpit, so for direct tactile interaction with the optical see-through head-mounted display, as Christophe described earlier. So the pilot can look at the real displays, can interact with the real cockpit instruments, looking through directly with his own eyes, looking at the cockpit directly. So a direct tactile interaction with the cockpit. A high resolution urban database with 3D models, as I mentioned before. Wind simulation around structures, moving models using AI engines, simulated ATC, and also all of the supporting simulator systems that will be used to plan, manage the training sessions and control the simulation, but also to guide, assess, and optimize the trainees' learning path. So we believe that the optical see-through mixed reality system, combined with this physical cockpit for tactile interaction, and with this mini motion system that you see in the picture, is the closest equivalent to what we know today as a level D full flight simulator. And so we believe that this is the best solution for the advanced air mobility pilot training. It will offer the highest fidelity training product at a fraction of the cost of a full flight. Note also that there will be fixed base variants of this product that will be available as well. And a last note to say that although this product is definitely designed primarily for pilot training, but it can also be used and deployed as an early engineering simulator to support aircraft design phase and certification activities. And to conclude on this, the optical see-through mixed reality simulators will not only be used for advanced air mobility training, but also for other types of training, other aircraft types, rotorcraft training, and more. Before concluding, just a quick note about remote piloted aircraft. Most advanced air mobility aircraft are designed with a mid or long-term plan to transition from single piloted to remote piloted operations. So on the training devices side, we will be ready for this transition, as in fact, there are some generic training solutions and products that already exist today for the remote piloted aircraft and the UAS aircraft in the military side. So these solutions will be the starting point for the development of cost-effective training products for the civil remote piloted aircraft when they are released. And on the slide, I show a few examples of RPA tuners that do exist today. So to conclude, we are going through a training paradigm shift in DNS pilot training, as Christophe presented earlier. The XR technologies have reached a maturity level that we think now makes it possible to develop new training solutions that could not be envisioned even only a few years ago. And civil pilot training will benefit as well from these innovations. And advanced air mobility, we think, is one of the first markets that will embrace the change. The gaming engine capabilities combined with advancements in artificial intelligence contribute to enhanced synthetic environments, which will be key for the urban environment pilot training. And now over to you. What do you think? How do you rethink the Rotorcraft training ecosystem? Questions and comments are welcome, and thank you all for attending.
Thank you, Vincent. Yeah. And sorry if we took a little bit longer than the slot. We apologize for that. I'm too passionate around my topic.
Okay.